Hello everyone. In this video, we are going to see all about zero copy cloning feature in Snowflake. Zero copy cloning is one of Snowflake's powerful feature that allows users to instantly create copies of database, schemas, or table without physically duplicating the data. This clone mechanism is fast, cost efficient, and play a vital role in enabling dev and test environments, backups, and branching workflows. This diagram illustrates how zero-copy cloning works in Snowflake. On the left, we have customer table. This customer table is our original table which contains metadata that points to the physical storage. This physical storage is nothing but the micro partitions. When we clone this customer table, Snowflake simply creates a new metadata pointer that points to the same physical storage. By doing this, we are seeing that data is not physically copied when we are doing cloning. Only if changes are made to clone or the original data, Snowflake uses copy on write mechanism and stores only the modified data separately. This architecture enables instant cloning, cost efficiency, and safe environment without affecting the source data. So what really happens when we do the cloning? Snowflake has a metadata-driven architecture. Snowflake architecture is built on metadata pointer and immutable micropartitions. When you create a clone, Snowflake doesn't duplicate the data. Instead, it creates a new set of metadata pointer for the clone that reference the same micropartition as the source object. Snowflake has immutable micropartitions. These micropartitions are optimized compressed storage unit that are never modified. So when you create a clone, both the source and the clone shares the same micropartition. Snowflake uses copy on write mechanism. That is, both the source and the clone shares the same physical storage unless one of them is modified. When the data in the source or the clone is modified, Snowflake creates new micropartitions to store the changes. This ensures that only the modified data consumes additional storage. From the production database, we have cloned a testing database and a development database. So a new metadata pointer for the development environment and for the testing environment will be created, and the metadata pointer points to the original data which is in the production. Suppose after cloning we are creating a new table, that is table D, in the development environment. Only for this new table, new micropartitions will be created for this development environment. Now let's see the benefits of zero copy cloning. The first benefit is its instant cloning. Snowflake creates clones almost instantly, no matter the size of source object. The next benefit is its storage efficiency. No additional storage is used until changes are made to the clone. The next benefit is its flexibility. Clones are independent, so you can modify them without affecting the original. The next benefit is its time travel support. We can even clone object as it existed at a specific point of time. Now let's see what are the database objects that can be cloned. In Snowflake, you can clone a wide range of database objects using zero copy cloning. This object includes databases, schema, tables. Table includes the standard table, dynamic table, Apache Iceberg table, and event tables. You can also clone database roles and various schema level objects such as alerts, file formats, sequences, stages, streams, and tasks. Now let's see some of the practical use cases of zero copy cloning. Here is our employees table that we created in our previous video. Let me select this table. Here is the data. This table is in Azure integration schema. I'm going to clone this schema and create a new schema. My new schema name is Azure integration clone. Let me create this schema. My new schema Azure integration clone is successfully created. Now I am going to clone this employees table and I am going to create a new table called employees clone. Let me create the employees clone table. Within seconds, my new employee clones table is successfully created. Let me select the employees clone table. Here is the data that is copied. Now in the employees clone table, I am going to change the age of Doe. Currently his age is 40. I am going to update it to 20. Let me run this. For the employee Doe, I am going to update the age as 20. Now let me select both the tables. In the employees table, we still see that the age is 40. Whereas in the clone table, we see that the age is updated as 20. We see that in the cloned table, the data is independent of the original table. Now, from the clone table, I am going to create a new table called employee clone 2 with the offset as 5 minutes. Now, let me create this new clone table. Now, let me select this table. So, if you see here, before 5 minutes, the age is 40. Whereas in the clone table, we see that the age is 20. We did a time travel and we cloned this table and we created this new table and we retrieved the previous data. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I'll see you in another interesting video. Thank you.